All right, so this is going to be 1.2 physical properties of matter. 1.1 was the classification of matter that we did the past couple of days with no real formal notes, but just through the POGIL and through the videos that we had watched, that is what I'm considering 1.1 classification of matter. So let's take a look at the physical properties of matter. Really, a physical property is defined as something that can be observed without changing the chemical makeup of the substance. So if we can just look at an object, we don't have to do any chemistry with it. We don't have to blow it up. We don't have to burn it. We don't have to dissolve in acid, anything like that. We're not changing the chemical makeup of the substance. That's a physical property. And we have really two different types. The first type is an extrinsic physical property, which depends on the amount of matter present. And so these are going to be like mass. Obviously, more mass, then that's an extrinsic property. That's going to change the property, right? Volume. Okay, that depends on the amount of matter present. Okay, usually if you have more volume, you have more matter. And let's see, weight. Okay, that depends on the amount of matter present. An intrinsic property, on the other hand, is going to be something that does not depend on the amount of matter present. Okay, density, like we talked about with the floaters and sinkers activity, density is an intrinsic property. And so what that essentially means is if I have a piece of granite that's about as big as my hand, or if I have a piece of granite that's as big as the Rocky Mountains, both of those pieces or samples of granite have the same density. Other intrinsic properties would be like texture, taste. You know, if I take a small piece of steak and I eat it, and then I eat an entire piece of steak, both of those pieces of steak should have the same taste. And melting and freezing point would be another example of something that doesn't change based upon the matter present. Water is going to freeze at 0 degrees Celsius, whether you have a lot of it or you have a little of it. Let's go a little bit further into density. A formal definition for density is the mass of a given substance per given volume of that substance. So it relates to two things. It relates to mass and it relates to volume. Mathematically speaking, if we want to look at how to work with density using some variables and using an equation, where I was going to look at this. Density, which is abbreviated with a D, equals the mass of an object divided by that object's volume. Okay, and we're going to play with this a lot in class. So D equals mass divided by volume. And when we do that, mass has a unit, usually grams, and volume has a unit, milliliters or centimeters cubed. So density, too, will have a unit. So the units that we use commonly for density, grams per milliliter when we're talking about liquids like water, grams per centimeter cubed when we're talking about solids like sand, and grams per meter cubed when we're talking about gases, because gases have such a low density. Now, over on the lower right-hand corner of the slide, there's a bunch of examples of substances, and what I'd like you to do is to write down like 3 of them. Try to pick one gas, one liquid, and one solid, and use those as examples of densities and how much densities can fluctuate between material. One way that I really like to express density in class is by using an MLD. Now, MLD is an important little shortened acronym that I'll use a ton, and it stands for a molecular level diagram. And what that means is that we're looking at the molecules, okay, and what they're doing. And here I'm using smiley faces. It doesn't matter. You can use stars or triangles or whatever you want to use. But the molecular level diagram shows you what the molecules essentially are doing at this very moment, okay? So if you look at a gas, the molecules in a gas are very, very spread apart. In a liquid, they're closer together. And in a solid, they're the closest yet. Now, each one of these samples, the gas, the liquid, and the solid, as you'll notice, is the same exact volume. The box is the same size. The difference being the amount of particles in the box. And so it would be quite obvious to say the gas would have the least mass, the liquid would have the middle amount of mass, and the solid would have the most mass. And because of that, we could then say, well, then our density is lowest on the far left and highest on the far right. Now, is it possible to have a gas, a sample of gas, that's more massive than a sample of solid? Sure it is. If you take all the gas in the entire world, in the atmosphere, and you combine it, that's a lot of mass. There'd be a lot of mass there. And if you compare that to like a paperclip's a solid, there's not a lot of mass there. The mass of the gas would far outweigh the mass of the paperclip. But if I ask you this, which one has the higher density, it'd be the paperclip. How do I know that? Well, drop the paper clip. Okay, the paper clip's going to fall. Okay, it's more dense than the air that it's falling through. What are some applications of density? Well, one of the first applications that I thought of was antifreeze. Antifreeze gets put in your car, it mixes with water in the car to protect it against freezing. You could understand that ice inside of your engine would be a bad idea. Now this little thing in the bottom, lower left-hand corner, actually tells you how much antifreeze is in your car. You extract a little bit with the bulb, with the tip in the lower left-hand corner, and it measures the density. Now the density of a mixture decreases with a decrease in antifreeze. And so if you have a low density mixture, you know you're losing some antifreeze, and you know you need to replenish it. So when you bring your car into the shop, you have it looked at, they're going to test the antifreeze. Oh, it looks like you got, it's a little bit low, then they can top you off, and so you're in good shape for the winter. Another good example of this is alcohol content, and I don't know if this is going to go away, if the image is going to go away. So I'll just kind of talk about it. I'll put that up there. We can read the density to find the percent alcohol in a mixture, okay? And so the way that we do this is we use something called a hydrometer. The more fermentation there is, okay, as fermentation is occurring, the more the density of the mixture is going to drop. Alcohol has a lower density than water does. And so we use this object in the lower right-hand corner called a hydrometer. And as you put the hydrometer in the alcohol, if it floats like it's doing right now, it's really floating, that means the alcohol content is high. If the hydrometer is sinking, that means the alcohol content is low. Again, it's completely based on density. So there you go. Physical properties of matter, and then focusing on one of the main ones that we worry about in this class, which is density.